So looking at example 1, we're graphing y equals x plus 3 times x plus 2 times x plus 4. So this is a quadratic in intercept form um, where we have some key features to identify as well. So the first thing that I notice are the two intercepts, x equals -2 and -4. So I'm going to plot points at those intercepts. So I'm going to list them, -2, 0, and -4, 0. So I know I'm going to look directly between the two. -3 is going to go to the middle of my table. So as long as you have your intercepts graphed in the correct spot, we're just taking what's directly between them, and that's how we're going to find our vertex. So -3 something is going to be our vertex. So it's going to be 3 times -3 plus 2 and -3 plus 4. So that's like doing 3 times -1 times 1. That gives us -3. So we're down here at this point. And finally, for our y-intercept, that occurs when x is 0. So I'm going to put in 0 for all the x's. So that's like doing 3 times 2 times 4, which does give me 24, which is too big to graph. It would go way off, but I can still calculate that. At this point, that's as many points as I really need to graph. So I'm going to sketch it in. All right, in problem number 2, again, we are graphing here. Before we get too far, I just did want to mention that if at any point you want to pause the video to try it on your own and then resume to check, that would be a good strategy to make sure you're on the right track. Number 2 is already in vertex form, so we pull the vertex directly from the equation. The inside value is our x, the outside is our y. So when we find it, we go inside opposite, outside same. So our vertex is 2, 4. I then fill in points around it to plug in as I graph. So as I go to plug those in, I'm also going to identify what the vertex is. I can pick either 0, 1, or 3, 4 to plug in. Either way, I'm going to get the same thing. All right, when I plugged in 0, I got -4, which means 4 will go to -4 as well. I'm then going to plug in 1. When I plug in 1, I get 2. So let's go ahead and graph it. 0, -4, 1, 2, 2, 4, 3, 2, and finally 4, -4. Now I can go ahead and connect them. We are now on to our review of key features of graphs. So it's been a little bit since we've talked about key features, but it is something that will keep coming up no matter the unit that we're on. So it's important that we start to master these. When we look at the key features, I would encourage you to start with the vertex. Once we find the vertex, it opens up a lot of other doors to find some other key features. The vertex of this graph is the point where our graph changes directions. That ordered pair is 3, 9. 3, -9 rather. If I know that that's my vertex, my axis of symmetry always starts with x equals, and whatever value we found for the x value is the axis of symmetry. Our domain is kind of like our giveaway question here. That's always going to be the same for quadratics, -infinity to infinity. That's all of our possible x values. Our range is all the possible y values. Our lowest one is -9, and it's going to go all the way up to infinity. We have one y-intercept on this graph, which is 0, 0. We have two x-intercepts. Those are the spots where the graph touches the x-axis. This one happens to overlap with our y-intercept. It is 0, 0, and 6, 0. Now we're down to increasing and decreasing, which we always kind of struggle with. But if we found that our axis of symmetry is 3, that helps us decide where we're increasing and decreasing. So I know that my graph is going up on the right side as x's are getting closer to infinity. and decreasing on the left where my x values are getting closer to negative infinity. So we increase from 3 to infinity. And again, whatever value I got for my x-intercept, that's the number I should be filling in. And then we decrease from negative infinity to 3. They always have that point in common. And finally, our end behavior. I notice that both of my endpoints are going up, so my end behavior both goes to infinity. So if they're going up, you fill in positive. If it's going down, you fill in negative. All right, for questions 9 and 10, we are solving those systems both graphically and algebraically. Now, this is just for practice. You will be given one algebraically and one graphically, but they won't be the same problem. So if I was doing them algebraically, I would set these two things equal. And solve for x. So I'm going to add 2x on both sides and add 3. And I'm left with 0 equals negative x squared minus 4x minus 3. I'm then going to factor out that negative because I don't want to factor if x squared is negative. And now I'm going to do x method, where 3 would be on top, 4 would be on the bottom. Those two numbers would be 3 and 1. So 0 equals negative x plus 3, x plus 1, and now I'm solving, where x would equal negative 3 and negative 1. When I solve, I flip those signs. Now I'm going to plug those back in to find our y values. I know that my solutions, my ordered pairs, will start with negative 3 comma something and negative 1 comma something. My job is to find those y values. So I can pick either one to plug it back into. I'm going to pick the top one because it's linear, so the negative 2x minus 3 one. So if I plug that in, y equals negative 2 times negative 3 minus 3, which will give me 3. So my first ordered pair, negative 3 comma 3. I'm then going to do the same thing with the negative 1. So we're going to have y equals negative 2 times negative 1 minus 3, which will give me negative 1. So now we're going to go ahead and work backwards and graph it. We should see that they intersect in the same spots. This graph is written in standard form. So step number 1 will be to use x equals opposite b over 2a, which will be positive 6 divided by 2 times negative 1, which starts at negative 3. So when I go to plug that negative 3 back in to find my vertex, it should look like this. Make sure that that negative 3 goes in parentheses, and that we include that negative sign at the beginning. When we plug that in, check to see that we are getting a positive 3. So when I go back through and create my table, that's what's going to get filled in first. Negative 3, comma 3. I can pick 2 points above, 2 points below to plug in as well. So I'm going to pick the top 2 to plug in. Negative 5 will give me negative 1, which means negative 1 will also give me negative 1. I'm also going to pick negative 4, which will give me 2. So now let's go ahead and graph that quadratic. Negative 5, negative 1, negative 4, 2, negative 3, 3, and so on. Our quadratic will look like this. And now we're going to go back and graph the line to see the points where they intersect. The line is negative 2x minus 3, so I'm going to plot my y-intercept. And then my slope is negative 2. Now this one won't be super effective if I go down and to the right. So instead I want to go up and to the left. So I'm going to go up to left 1 until I see the points where they intersect, and I can already see those two solutions. Ignore my terrible graph, but those two will intersect at, sorry, not that point. They will intersect here and here. So negative 1, and negative 3, 3, which is what we found algebraically. it graphically first. So this one, we're going to graph the line. The line is x plus 6. So I'm going to start at my y-intercept, which is 6. Slope is 1. And now I can go ahead and draw my graph in. And I'm going to use my line tool to draw it a little bit more accurately on the test. If you want to use some sort of straight edge, that would probably be a good idea to make sure that you're seeing the exact point where those lines will intersect. So now I'm going to go back up, graph the quadratic. This quadratic is written in vertex form. So when I create my XY table, the vertex comes directly from it. It should be -3, +1. I fill in points around it to find my y values. So when I plug it in, I'm going to have -5 plus 3 squared plus 1. That gives me 5. And -1 goes to 5 as well. When I go back through and plug in -4, I get 2. So now let's go ahead and graph it, see what we get. And we can see that this one, again, hits in 2 different spots. So my 2 solutions look like -1,5 and -4,2. Now, when we do this algebraically, we should be getting the same thing. So let's go back through and do it algebraically. This one will be a little bit trickier because we do have that parentheses squared in there. So we will have to FOIL. So we're going to set x plus 6 equal to x plus 3 squared plus 1. So I'm going to start by FOILing this out, which you will not have to do on the test, but it's good skills to practice. So that's like we multiply x plus 3 by itself, which will eventually give me x squared plus 6x plus 9. I bring down that plus 1, and then we can go ahead and start to move some stuff around in order to factor. So I'm going to subtract x because I need this equal to 0. Subtract 6. So I'm left with 0 equals x squared plus 5x. Looks like plus 4 at the end. Eventually, once we do x method, this will factor into x plus 4, x plus 1, where x will be equal to -4 and -1, which is the 2 x values that we found. So now I'm going to go back and plug them back in to find the y values. Okay, so if I plug in -4, I get 2, which makes sense because that's what we found on our graph. I'm going to do the same thing with the -1, which gives us 5 as what we found when we graphed. So moving on to the next one, we've got y equals 10 and y equals x plus 3 squared plus 1. So I'm going to start algebraically. So I'm going to set those two functions equal to each other. They're both already equal to y, so we're good to go there. So 10 equals x plus 3 squared plus 1. From here, we're going to subtract 1 on both sides. So 9 equals x plus 3 squared. And then we're going to square root both sides. So square root of 9 is 3, and we need the positive and the negative. And then we're going to split it into our two functions, or two equations rather. So positive 3 equals x plus 3, and -3 equals x plus 3. In either case, we're going to subtract 3. So I know my first solution is 0, and the second is -6. Now, the good thing about this function is they tell us that y is already equal to 10. So even if I took 0 and -6 and I put it into this function, it would give me 10. So our two solutions are 0, 10, and -6, 10. And now when I go back to graph it, I should get solutions at exactly those 2 points. So I'm going to start by graphing y equals 10. That is a horizontal line all through 10. So I'll go ahead and graph that, add my arrows onto the end. And now I'm going to move on to the quadratic. So we've got x plus 3 squared plus 1. This is a quadratic in vertex form. So I'm going to create my table. And first point I add to it is going to be the vertex, which is -3 and +1. So the inside flips, the outside stays the same. And now I'm going to go 2 less and 2 more than the vertex. And I'm going to substitute those points in. So I'm going to start with, I'll start with -1. So we're going to have -1 plus 3 squared plus 1. So -1 plus 3 is 2. 2 squared is 4. Plus 1 gives me 5, which means that -5 also has to go to 5. I'm going to do the same thing with -2. So -2 plus 3 squared plus 1. -2 plus 3 is 1. 1 squared is 1. And 1 plus 1 is 2, which means that -4 goes to 2 as well. So now I'm going to go ahead and graph this. So -5, 5. -4, 2, -3, 1, and so on. So I notice that my quadratic is down here right now, but my arrows will continue to go upward. So to find the exact points where they intersect, which we already know where they should be, but assuming that maybe I haven't done algebraically already, I've got to be able to prove this graphically. So I'm going to add 2 spots to my table. So I'm going to go 1 more on either side and then plug it in to find where they intersect. So I'm going to pick 0. So 0 plus 3 squared plus 1. 0 plus 3 is 3. Squared is 9. Plus 1 gives me 10. So now I can see exactly where they intersect. And that proves the algebraically that we already found. So 2 solutions at -6, 10 and 0, 10. Number 6 is y equals x minus 8 and y equals 2x squared plus 4x minus 6. So again, I'm going to start by solving this one graphically to see where they intersect, and then we will do it graphically. So again, starting algebraically, then moving graphically. So for algebraically, I'm going to set those two functions equal. So x minus 8 equals 2x squared plus 4x minus 6. So before I can do anything, I've got to get it equal to 0. So I'm going to subtract x on both sides and then add 8. So we're left with 0 equals 2x squared plus 3x plus 2. If I tried to factor this, I'd be looking for numbers that multiply to be 4. 2 times 2 is 4, that add to be 3. Now, if I had a negative up here, I could make it work, but the only positive factors of 4 are 4 and +1, or 2 and 2. Neither of them add to be 3. So if I can't factor, I've got to do quadratic formula. So the formula itself is opposite b plus or minus square root of b squared minus 4ac all over 2a. So when I go to substitute in, opposite of b is -3 plus or minus square root of b squared, so 3 squared minus 4 times a, which is 2, and c, which is 2, all over 2a. So when I do quadratic formula and I start to simplify, I want to start with the part underneath the radical. That's called the discriminant. It won't always give you no solution, so I do want us to be careful of that. Just because we're doing quadratic formula doesn't mean that we're going to get no solution. In this case, we will, but quadratic formula could also give me decimal spots as well. So I'm going to type in the discriminant. We get -7 over 4. So in order to prove that this is no solution, I have to show that there's an I in the answer. So this is going to be -3 plus or minus I root 7 over 4. So the negative underneath the radical comes out as an I, and that would prove that this is no solution. So now when I go back and do this graphically, that should be shown as well. So our line is y equals x minus 8. So I'm going to plot my y-intercept at -8. My slope is +1, so up 1, right 1. And I'm going to plot points until I can't plot points anymore. I'm also going to go down 1, left 1. And then I'm going to use my line tool in order to draw a nice straight line through all of those points. And again, we should be seeing that this is no solution, so be on the lookout for that. So then when we go back up and look at the quadratic, this is a quadratic that's written in standard form. So first step when we're in standard form is to use the formula opposite b over 2a, where the opposite of b is -4 divided by 2 times 2. Now when you do this, I would caution you against just typing this into your calculator, because if you don't include parentheses around the denominator, it's going to divide -4 by 2 and then multiply by 2, which is not what this is. Instead, 2 times 2 is 4, and -4 divided by 4 is -1. So now I'm going to create my table where -1 goes directly in the center. I'm going to go 2 less and 2 more than the vertex. So I'm going to start by plugging in this -1. So it's going to be 2 times -1 squared plus 4 times -1 minus 6. -1 squared is 1 times 2 is 2 minus 4 minus 6. That's going to give me -8. And then I'm going to go ahead and find the other points. Now 0, that's an easy one. Y-intercepts occur when x is 0. So if I put in 0 for x in both spots, I'm left with just -6, which -2 would go there as well. And then one more point I have to find. So I'm going to plug in 1. So 2 times 1 squared plus 4 times 1 minus 6, which is like doing 2 plus 4 minus 6, which gives me 0. So now I'm going to go back and graph those points. So -3, 0, -2, -6, -1, -8, 0, -6, and 1, 0. So we do, in fact, see no points where these graphs intersect, so it does prove that it is no solution. Let me make that a little bit straighter. All right, there we go. So no solution, those graphs do not intersect. Finally, moving on to the last one, we've got one more set of key features to figure out. So I'm going to actually skip over axis of symmetry for now. Instead, I'm going to find the vertex first, because then I'm going to use that information to find axis of symmetry. So our vertex is the very top of this function, which is located at the point -3, 4. Now I'm going to go back and find axis of symmetry, which always starts with x equals. If you leave that x equals off, you will lose points. And then we're going to find whatever that x value was of the vertex, which is -3. So that's like a dotted line. If I were to draw it through -3, that would split my function in half. Domain for all quadratic functions, that's all our possible x values, is -infinity to infinity. This one has a maximum value that's the same as the vertex. Our range goes from bottom to top, -infinity up to 4, and 4 gets a bracket. That's all of our possible y values. We have a y-intercept located at 0, -5. We have two x-intercepts, one at -5 and the other at -1. And I want to write those as ordered pairs. So -5, 0 and -1, 0. If we've already found axis of symmetry, that helps us identify our increasing and decreasing intervals. So for increasing and decreasing, we only care about the x values as we look from left to right. So the left side of the graph is increasing and the right side is decreasing. And our switching point is located at -3. Our left side, we know if we're looking at x values, goes all the way to -infinity, and our right side goes to +infinity. So our increasing interval goes from -infinity to -3, and our decreasing interval goes from -3 to infinity. All right, and the last one is end behavior. End behavior identifies what the endpoints are doing. Both of our endpoints are going down to -infinity. quadratics always go the same way. So if both of them are going down, we should be filling in negative infinity for both. If, for example, they were both going up, then I could fill in positive infinity.